Good morning, everyone. Welcome to the 13th session. We continue to learn chatbots. Over to you, Dr. Logi.
Colab is uh, right now they have not upgraded their Python to support the OpenAI. So therefore, we cannot directly connect to OpenAI using Google Colab, right? So therefore, what we are going to do is we are going to connect to Langflow, and we will use that thing to build our chatbots. Okay. So first, let's understand how this thing is going to work. First, let's start with the PDF semantic search. So in the previous lectures also, we went through a certain PDF semantic search, how we chunk it, and how we identify the certain queries, right? Based on the embeddings that we make. So in this tutorial, I will upload a PDF file. So after that, the PDF file will be texts will be extracted from the PDF file. Then we will use a sentence transformer to chunk the thing, tokenize and chunk them. So tokenization means separate the words, word by word, and comma, full stop, and everything. Chunking means taking 200 tokens or 500 tokens as one paragraph, one paragraph. So finally, when you ask the query will be also transformed into embeddings, semantic embeddings, and it goes through each chunk to identify which matches the query embeddings and find the best 503 out of that and send it to the GPT. Then the GPT restructure and send it to us. So that's how the PDF searches are happening. Even the ease of bot that we have discussed, right? Ease of bot during last lectures. Nowadays, ChatGPT bot is open. So you can have anything over there, right? You can ask about law, you can ask about medicine, you can ask about Sri Lankan stuff, curries or whatever. But in certain cases, you cannot go and ask about Sri Lankan curry to use of chatbot, right? How to make parapu curry, it will not answer. Because their knowledge is limited to a certain database. So how we give the database? Basically, we extract all the information from the websites. Then we get the text and that as a text file. Then we embed as a PDF. Then from the PDF, we extract all the text. So that is the vector database, vector DB. So it has the embeddings. So when you query will get embedded, go through the vector database, identify the relevant chunks, put it over there to GPT, GPT give the answer. That's what you are getting. So now just to refresh the memory, we have done it earlier too. So we are going to run this one. First, I will upload this PDF something over here, which I have right now in the computer, right? This is a PDF semantic search. So once you play it, the first block, it'll open up the PDF. You can upload whatever the things you want. I'm going to upload something called data for the bot. So this is another bot we are working on for Decryptogen. Decryptogen is another company, AI company, not AI company. They are software company. They are trying to promote their AI services. So they collaborated with us and said they want a chatbot for their company. So we have created. So for that, what we have done is we went there and we scraped the data from their internet website and we have created this database. Okay. So now this database has this much of pages having all the information about Decryptogen. So most of them are scraped from the internet. Certain information they have provided, right, which is not readily available in the internet. For example, the contact number and how to about the person who started the company and certain projects that they have completed, ongoing projects. So those informations are there. Externally they gave. Other than that, most of the information, these informations are scraped. So whatever you have seen here are given by them. From this point onwards, you can see the font is different, right? So these are scraped information from the internet, scraping. So there are certain tools available. You just put the internet like link. It'll go through the link, scrape the data, save it as a text file. Then you copy paste or you can use the text file directly to embed it. That's fine. Extract the text and embed it. So is scraping legal? You put a link and you scrape the data and you make something out of it. Is it legal? It is not, right? It is not legal. But at the same time, all the softwares working in online, including Google, ChatGPT, everyone, they does it. They did it in the past. Nowadays, it becomes a issue after OpenAI releases. Google and other people are trying to make it as an issue because if the scraping is illegal, GPT cannot get trained. It's trained on the public data. They scraped all the information from the internet, open source information, all the website, everything, right? So if they stop scraping, GPT cannot be trained, right? So scraping is legal when you have the approval from the website. For example, I want to scrape certain information from your website, Decryptogen. Decryptogen gave the permission to me to scrape the website, right? So similarly, we have built up certain example cases for some hotels, right? Hotel chatbot. You can book a room in say Hilton or some places. So to scrape the detail information and everything, we need their uh, approval to do that. Otherwise, we cannot. So for ease of bot, we got the approval and agreement where we can scrape the information time to time and we can update it, right? Updating means what? Only you are going to update the vector database, right? Rest of the things are there. You scrape the information, update the vector database time to time. So when the person come and ask the query, it's going to go through the updated web database. eSoft is not going to be updated frequently because the fixed courses are there. But if you take, we built another chatbot for a, I worked on a platform called Go Rewards. It's a POC. So there, the Go Rewards is a rewarding platform. So they give rewards if you purchase in certain supermarkets and everything. So for example, if you have a Go Rewards card, book your flight through the Go Rewards credit card or something, they give certain points. So accumulated points, you can use it for some other purchases. You can buy supermarkets, or you can book another flights, something like that, right? So there are a lot of partners available. Go Rewards, it's a Philippines one. So what we have done was there every day you have to scrape the data and update it. The reason every day new offers come. They post new offers. They post new point system. So it need to be upgraded all the time. So what we did was during the less usage time, midnight around 2 to 3 a.m. So we temporarily shut down the system automatically. It goes through again the like database, extract the information, put it into the thing, and create the new vector database. That's all. Once it's created, any people come next day morning, ask about what are the ongoing offers, it's going to answer the new offers. So there are certain things. So here the Decryptogen, we have created certain like web scraping. It's nothing. You put the link and run the code. So this is the code for that. Which is called, give me a second. This is my WhatsApp. Okay, here we go. Okay, let me put that one. This is the code that we use for scraping. So some library called Beautiful Soap, right? So that's the thing. We have used over here. So just you have to add the links that you want to scrape, right? What are the links that you want to scrape over here? You can put it over here and just run it. So let's go through what is this SIST, right? SIST, we will go SIST and we'll select a link over there. Spectrum Institute, right? Maybe about us. We'll go here, our story. Okay. So this is our story. Let me go here, copy the link, go and place it here. Let's run this one. Only one link I'm going to scrape, right? Yeah. I'm going to run this one. Pips installed, torch and everything. So this is not there in your thing, right? So I'm just showing how it's extracted the databases, right? When you are going to build up a chatbot. So basically, the vector database is going to be the data that we are going to provide it for the chatbot. It's not open. So there are certain issues can come, right? When you are creating a chatbot, like in the chat GPT, when you are typing certain thing and you ask a question and it give an answer. So based on the answer, you can ask another question. So you can continue the chat, right? As talking with a human being, right? For example, you are talking about a chat, something like let's open up a chat and we'll practice it out. Okay, after showing this one, so it's called Playwright install. There are a lot of ways to scrap the data. Much more libraries available. So we are using the Playwright scrap to do that thing using the LangChain also. So it's get that LangChain community. So which helpful to scrap the data in a structured manner. Otherwise, it's just scratch and put it over there. When it's embedding, the semantic meaning will be missed. So we need the LangChain to do that thing. So we got that thing. After that, just click this part, adding the link over here. I can share with you this one also. So you can use your own thing to get that part. Okay. So I'll share it. Okay. In the AI. Okay. So it's scraped. So once you go here, scrape content, you can open it up. So you can see Life Sciences, BSc Hons. Let's download it. Okay. It's a text file. By the meantime, I will copy and paste over here. Okay. Said you can open that also. So now we will go to the download and see what it has downloaded. So these are actually without the consent. If I'm doing it, it's illegal, right? But many people do it. Many people do it. So there are certain things called social listening. Have you heard about that word? Social listening. So there is a project, one company involved in from Philippines. Uh, it's a food chain, Shakey's. Okay, so what they do is they want to monitor the social media platforms, including TikToks, Instagram, Facebook, Twitter, everything regarding their shop. So what certain places have allowed is we can openly scrape the data from the website by typing Shakey's, find out all the keyword search and find out the information and go through the semantic search and identify is it a positive comment or negative comment. But it's illegal, right? So there are certain places the Facebook allow us to scrape the data. So through those APIs, that means through those platforms, we can collect data. But now data is becoming very sensitive thing. So we have to be very careful without scraping the information without a specific website permission. Okay. So make sure. So these are the things it's scraped from here. You can see a Spectrum Institute of Science Technology. Even you can see home, about us, contact us. Why? Because once you go there, you can find about us page, about us admission research, all these things will be scraped. Whatever the things over here, life science and engineering information, everything will be scraped and put over there, right? So, but that doesn't matter for to build up a chatbot. So let me open up the text again. Yeah. So see all these things, EU model, something, laboratory molecule. These are in that web page. So you can see the whole content is downloaded. So let's copy this place. Copy. Can you run it? We'll build a chatbot for this one. Go to the Spectrum Institute. Open up the, let's go by one. Go to your thing and go to your web scraping tool, right? It's added to this thing, 13th week, right? Open up the web scraping and go to Spectrum Institute, about page, about us page, right? Then get that link and paste it over here, right? Paste it over here. So there are three links I have added that is for Decryptogen. So you can just place inside that thing and there is a comma. You have to remove that comma at the end and run all these things. Okay. So once it run, you will find the text document. So I'll wait until you do it. Okay. So that's how we get the content for the chatbots. Is it not working? Can you find it? Can you refresh the page again? Here at the bottom, first run one by one. First, second column, install the required libraries, Playwright install. After that, here, the third block, you can find there are three links I have added. Decrypto something. Just remove those links and add one link over there. That's all. Here, you can see here, like this. Yeah. There's a comma is there. Then remove that comma. Then play all the things from the top. Then you will be able to get the information from the Spectrum campus.ed.lk about something, about page, right? So now there is an issue. If you go to this Spectrum Institute, there are a lot of our history. There are a lot of informations are there. So what we do usually when we scrape a data, we do not go through link by link and copy all the links and paste. How many links are there? Sublinks are there in this website. We want to scrape the whole information from the website. You can't copy all the links. For example, when you go to eSoft Metro Campus, that website itself have more than 100 links. You can't go one by one and get that thing. So there is something called sitemap, right? Sitemap. For each website, there is a sitemap. So in the sitemap, there are links. So what we do is we go download the sitemap and use that sitemap to extract the text file. So in the sitemap, they have added the link, sublinks and everything. So the scraper will go through all the sublinks, scrap all the data, save it as individual files. So then you combine them and make the vector DB for the database. Okay. So have you done this one? No, scrape the data. Okay. Scrape the data. So once you scrape the data, we will get this text file, download the text file. So last time we built a chatbot with keyword search and semantic search, right? With a certain content. Today we are going to build a chatbot based on the PDF that we are going to have. We have done scraping. Let me know. Done. So if you are done, copy all the data, open up a Word file, paste it over there, and save it as SAST or something, right? Open up a Word file, paste it all over there. So then, yeah. So this is the data that we are going to use for our chatbot, right? Okay. Then you can say file, save as PDF, SIST. You can save it wherever you want to. Then I'm going to save it in the downloads. Right? Save. Done. So now I have the database created for my work. So SAST. So this is the PDF that I'm going to work with. Say, see, all these things are there. Okay. How many of you have done? So you go here, you can find the scrape data from here. Then you can click here and download it. Once you created the database, we are going to move to the next one. Still scraping? Okay. So this is if you have few links. Otherwise, we go to the XML file and scrape the link, right? So that is the easiest way to scrape the whole website, each and every sub pages and everything. This is just for an example. You can give the link and scrape it up. In certain places, the people just block scraping, right? If you, for example, a website of American forces, you cannot scrape. You can scrap the data, but when you open the text file, nothing will be there, right? Because they stop it through certain security thing. So a certain message will be displayed. You cannot scrap the data or illegal to scrap the data or something. So it will scrap the data, but no content will be there. So they can block it from their side as well. But most of the companies, marketing and education institute, they don't block because they want their data to be used in many places, searches and everywhere, right? Even if Google is trying to search, so their keywords need to be there in the top 10. For example, computer science engineering degree, Sri Lanka means ease of want to come in the front. So to do that, let the Google scrap the data, right? And update it. So they purposefully do it. But American forces, they don't want to do it, right? So, so it depends on the purpose. Okay, have you created the database? All cool. So after that, go to this one and PDF semantic search. Second tutorial. So here we have done it earlier, similar kind of things. Today we are going to do a little bit different way. So let's go there. And anyway, right? Choose the file and you can SIST open up. Okay. So then it will open up, it will upload. Okay. Right. So we are going to run this. First upload that SIST by executing this thing. So this is going to be our database for our chat. Right. So we have proven in the last lectures, keyword search chatbots are not going to work anymore. Right. Basically, we have to go for semantic search. So when it comes to semantic search chatbot, what we have done last time, we have given the question and answers. And based on the question, it identifies certain. For example, there are famous people we have added. When we say, who are the legends in AI? It identifies the famous people and put the answer over there, right? But for the keyword search, it said I couldn't answer that question. So that is the difference between the semantic search and the keyword search. So for the chatbots right now that we are going to build, it's going to be semantic search because we do not have predefined question and answers at all. So if I ask who is the owner of this SAST, who is the founder of SAST, there is no answers directly. So now what we are going to do is we go through this database, identify certain information from the PDF and get that answers, put it to GPT and restructure. That's what we are going to do. So now we have uploaded the PDF. After that, certain PDFs may have images also, right? So in this, only text are there. So while you are scraping the data, you can scrape the images also. There is a way. I only scrape the text directly using this thing. You can scrape the whole website, including the images also. There is a way to do that, right? So for the chatbot, we do not need it, right? What we did is we only scrape the text. But if the PDF have images also, for the chatbot, we do not want the images basically, right? So only question and answer. So certain image of SAST founder J. So we don't want his image anymore. So what we do is we remove that thing. We need to only extract the text from the PDFs. So here we have only text. So there is no issues. But you have images in a text PDF file. So it will only extract the text over there and save it as a text information in the here. For that, we need to install this PyMU PDF. So this is to handle the PDF over there. So to extract the thing, so we created this text information. So it go through the PDF, right? It's a PyMU PDF thing. This is a library from PyMU PDF sub-library. So it go through the PDF document, uploaded PDF document, only extract this text and keep it in the platform. So since it's a very small PDF, it just quickly run it when you ran it, right? So that is done. So after that, we have extracted the text from the PDF, right? What is the next step? What we need to do for the semantic search analysis? We have to embed it, right? In the semantic way, embeddings. We have to tokenize and embed it, right? So that's what we are going to do. Second, for that, we have learned about the sentence transformer, right? Sentence transformer. So we need to install that sentence transformer to vectorize it and tokenize. After that, we are going to create chunks. First, we extracted the text. Now we are going to tokenize it. Tokenize it means what? Individual word, we are going to separate it. After that, we are going to chunk it. Chunk means what? Sorry, after that, we are going to embed it. We know for each word, we have given a number, right? So it has a meaning, it has a sentiment, it has a place where it holds. So for example, we took the bird and see there were 256 embeddings for one bird, right? 128 embedding for another model. So now we are going to do the embedding part. After doing the embedding, we are going to chunk it. Chunking means, okay, first 100, every 100 word is a chunk like that. Or every 50 word is a chunk. That's up to us, right? So let's see doing that part. So first we are going to tokenize the words. After that, we are going to create the chunks. Then after that, we are going to do the embeddings. Okay. So now let's do that part over here. So now you can see I have created 200 words or 200 tokens as one chunk. So in this document, there were total 21 chunks created. That means 21 into 200 tokens are there in the PDF. Total word count, right? Total word count. So for example, it says Life Sciences, BSc Honors, Microbiology, BSc blah, 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 blah thing. This is one chunk, example chunk created. Okay. One example chunk created from the PDF that we have uploaded. Chunk means it's only take 200 word, one chunk, another 200 words, another chunk, another 200 word, another chunk. Chunk wise, it's going to do. So you can change the wording side maybe to 10, right? When you do it for 10, you can see number of sciences only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 words are there to one chunk. So let's keep it as 10 now. Okay, we are going to do 10 verse chunk. So now the whole PDF document is divided into 10, 10, 10, 10 words. So totally we have right now 200, 402 chunks. So that means how many words in the document? 4020, but multiplied by 10, right? 402 into 10. So that's many words are there in the thing. So now we have chunked it. So now what we are going to do is we are going to identify the chunk based on our query. So the query we will change it over. Query means my question, right? I will ask who is the founder of SIST. This is the question that I'm going to ask. So now what is going to happen is the sentence transformer, it's going to be used this model, all mini LLM LV6 to embed the thing. So it's encode using the thing text chunks. So we have separated the chunks. So now what we are going to do is we are going to use the sentence transformer model to embed it each chunk wise, right? Chunk wise. After that, what we need to do? We also need the query to be embedded. Then only what we can do, we can go through these chunks. So let me draw it out. So now we have a PDF document, right? It's a text database. Let's say this is the text. Yeah, 10 word, one chunk, 10 word, one chunk, 10 word, one chunk. Like that, 10 words, 10 words, we are having the chunks, right? We are having the chunks. All are 10 word chunks, right? So the PDF document is full of chunks. We have separated up to 402 chunks are there in the PDF document. Now you are asking a question, right? Who is the founder of SAS? So now this query also, and this is chunk. Then after that, what we are doing? We are going to embed, right? Embed. So what we are doing is we are text vectors encoding. Encoding means we are giving a certain number for each chunk based on the meaning, semantic embedding. So what we are doing is we are embedding and we are creating an embedding vector base, right? So here chunks are there in the number format, right? So now we have done it, right? After that, what we are going to ask a query. So now the query, once it asks, it's also need to be encoded as an embedding. So now it's a number. There are multiple numbers over there. These are text. Using the sentence transformer, we have embedded and given a number for each chunk, right? Based on the sentiment. And we are getting the query and embedding this one, and we are getting a number. So now what we are going to do is we are going to search using cosine similarity, which is a search method, to identify what is the best match embeddings for this. So for example, the same thing that we have done more or less similar for identifying the face. We have a lot of embeddings database. This is the embedding for you. This is the embedding for you. We have a database, right? So when I take an image, I embed it first. Then that embedding, I search through the database to find out which face has the best embedding match with this image. Right? Then I found out, okay, this guy, his name is Logi, the uploaded photo is mine, have 85% match with this photo. So then I say that is Logi. The same thing. So here what I'm going to do, I have embedded, this is a number, vector number, where I each chunk have numbers as a matrix. It go through this and identify the best chunk. So we can select 1 chunk, 2 chunk, 3 chunk, 5, 10 up to our need. So here in this particular example, I have selected 5 chunks. So what it will do is it will go through that, identify, okay, this has a first match, second match, third best match, fourth best match, fifth best match. Then pull out those matches and it will display the chunk, right? So the query is a chunk, this is a chunk, right? That's what we are going to do in this code base. So now what is happening is I just type the who is the founder and I am embedding it and I am searching similarities, quality vector and the text vector. Text vector is the one that we have done from the extracted text. Okay. So text vectors and query vectors. So these two things are going to be gone through this vector base, identify certain chunks. So in this case, I have defined where I have defined the chunks numbers. Top K5. Here I define the 5. So let's select one number of chunk for the particular query. So when I put the one number, let's see what is going to happen. It's going through the database. First first chunk the text. Then after that, it's going through the database and searching it. Finally, it's going to give me the answer. SAXC are opposed to practical industrial research setting. This is the most identified chunk, suitable chunk based on the number of sets, right? I will increase the chunk size to 5 again. And let's say, okay, we'll run it again. Okay, these are the 5 chunks. SAST are exposed to practical industrial and research setting, part of SAST family, Jayanthan Kulasingham Chairman Spectrum Institute. So this is the another chunk which is related to my query, which has 0.5381. Second highest score. University of Mysore, India, the prestigious collaboration of SAST with learners and dynamic members in the society. SAST strength lies and citizens the role of SAST. These are the chunks I have found out. But still, let's see. I asked a query. I found these are the relevant chunks where my answer might be in, right? Why? Because I have added the chunk size as 10 here, right? Chunk size as 10 here. So now the next step, what is going to happen is I need to send this query along with the chunk to the chatbot. So for that, we need to install this one, pip install OpenAI stuff. And after that, we have to run this code with the OpenAI API key. So this is my API key I have added over there. So please don't share it in the public website. Otherwise, they will charge me a lot, right? So the charges will be coming to me. So after these lectures, I will cancel this one anyway. So once you install it, when you run this one, what this code supposed to do is, so it should take these chunks along with the query, right? And send it to GPT, and the GPT should answer back. But unfortunately, the Google Colab did not upgrade to get this thing. So it's not supporting right now. So 40 at most 4096. So let's see 4096. 4096. When I change it and play it, again, it might give an error. Okay. No. Again, I have to change the query. I'm going to send the query. It's working. Oh my God. Cool. Have you done this OpenAI 0.28? Is it there in your code? If you just install OpenAI, it's not going to happen. Is there any? Okay. Then install. And you have to change the query here. Right? Again. So what is going to happen is, it's going to run. And the chunk size, we have defined everything as 200 and everything. So what is going to happen is, I have defined the GPT 3.5 turbo. So we can put GPT 4o mini. GPT 4o, right? GPT 4o, again run it because it's the cheapest model right now we have. Okay, maybe this is not the way 4o. Yeah. Yeah. So now you can see the founder of the Spectrum Institute of Science is Jayanthan Kulasingham. It's got the answer. You get it, right? What I mean? So what happens is, it go through the chunks. Our chunk size is 10. So it's find out all these 5 chunks, best 5 chunks, and send it to the query, send it to the OpenAI with the query, and it structure it out. If you do the things, okay, go to ChatGPT, right? Go to ChatGPT. Okay. So open up a chat and say, place this one, right? Place this query first. Who is the founder of SIST? Okay. And go to ChatGPT and place, right? And place these identify chunks. Okay. Identify chunks. Right. Identify chunks. So now these are the things going to be there going to the ChatGPT. On top of that, we have to send the ChatGPT saying that you are an assistant, right? If you go here, I have defined something called in this part, you are a helpful assistant, right? Based on the following text chunks, answer the question. Query, join chunks, right? So this thing also, I need to place it to the ChatGPT. Along with these chunks, this thing also going over there to the GPT, right? I need to place this one, okay? Underneath that, I need to place this one as well. Based on the following text chunks question, place this one. So this is going to go there as well to the GPT, okay? So I need to say rather than that, this is, I will just put it as query. This is going to be the query. And these are the text chunks. So it will automatically done in the API code. So now I have created. So this is what going to the GPT, right? This is what going to the GPT when we run this cell, because you are a helpful assistant. Based on the following text chunks, answer the question. So this is the query and these are the join chunks. What are the chunks that we have retrieved? These are the chunks that we have retrieved, right? So it goes to the GPT. In the backend, we are using the API key over here, 4O model. So now I'm going to the GPT. I have the paid version 4O mini. So I'm going to enter this one. Okay. The answer is the founder of SIST is Jayantan Kulasinga. This is what you got over here, right? So something called temperature setting. What does that mean? This will have the freedom to change the answer. I'm going to send it again. 0. Set it to 0. The founder of the Spectrum Institute is Jayantan Kulasinga. You play it again. The founder of the Spectrum Institute is Jayantan Kulasinga, who is mentioned as the chairman of the provided text. Most of the time, you will get the same answer again and again. But if you change it to 0.5, the variety of the answers will be different. So the founder of specific is mentioned as the institute, okay? Jayantan Kulasinga. Second, third, it's giving the same. Maybe the chunk size is less, that's what it can do much. So we'll change the chunk size and play with it. So now I go back again, right? Now I go back again. You are a helpful assistant, right? Answer like Donald Trump. Answer like Donald Trump, right? I'm going to play this now. Maybe something went wrong. Okay. All right, folks. Let me tell you, the founder of the Spectrum Institute of Sciences Technology is none other than Jayantan Kulasinga. This guy, he's done tremendous job with me, talking like Donald Trump. So that is the power of the prompt. You're getting it, right? So you can ask him to change it. But what we have given, the same 5 chunks. The same 5 chunks. Only thing I have mentioned, answer like Donald Trump. That's all, extra. The same thing I'm going to go back to this GPT. I'm going to, this is happening in the backend, going to the GPT, coming back. So you can manually do that also. I'm going to copy this part, right? I'm going to copy this. Maybe I can edit it. Assistant, answer like Donald Trump and send. So now you can see the answer. The founder of he's a chairman. I believe me, he's holding incredible job, very smart, very capable. So this is what happening in the GPT. It's not a rocket science. So since you are building a chatbot or something, it's not a big task nowadays, right? Earlier days, the problem restructuring the answer. Chatbots were there, but you have to have a predefined answer for expected questions. Now you don't care. You just put it in, get it out, and let the GPT do the wording, right? The large language model do the wording. So that is now happening in the thing. So now you can see it's answer like a Donald Trump, it's giving something. If you change the temperature setting is kind of a little different. So it's going to be giving different answers each time. That's the temperature. Temperature 0 means what is the most used word after a certain word. Let's say the cat jumped over. If the fence is the most suitable word, or like most probabilistic word used in the training data, it will use only fence. How many times you answer with the temperature 0 setting, it's going to say fence. But if you increase the temperature setting to 0.5, it's going to say fence, it's going to say wall, it's going to be a chair, the varieties of answers. So answer variety will be different. Answer will be correct, but the way of answering will be different. So now we have seen the power of the thing. You can say answer like Donald Trump, maybe Obama. Let's say Obama. Okay, let's see how the bot is answering. Founder of Spectrum and Jayanthan Kulasinghe. That's all. Nothing else changed. Obama is a short answer guy. The founder of Spectrum, however, Jayanthan Kulasinghe identify the chairman of SAST, which suggests he may have played a significant role in its establishment and leader. Nothing I told. So what is the chunk it went? SAST are exposed to practical industrial research testing, first chunk. Part of the SAST family, Jayanthan Kulasinghe and Chairman is the Spectrum Institute, second chunk. University of Mysore, India, prestigious third chunk. Learners and dynamic member, fourth chunk. Citizens are all fifth chunk. That's all it went. Nothing else. So based on the chunks, we are getting a big thing. You are getting it, right? What is happening in the thing. So now let's increase the chunk size from 10 to maybe a size of a little bit larger size. Maybe 100. Maybe 100. Right? I'm going to change the chunk size to 100. Okay, 100. Then now we have 41 chunks. When I run it again, you can see now the chunk size is little bigger, right? The extracted chunks. Scientific research through our diploma, blah, 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 blah things. This is a large chunk. And it has a lot of information than earlier, right? So using this chunk, I'm going to go run it again. Right. I'll remove this Obama. Okay. Obama part, I'll run it again. You can see it's giving the answer, but the founder of the said he is mentioned in the chairman in the provider. It's giving the answer, but right now what you are doing is you are feeding more information to the GPT to understand more about SAST from the PDF that you have provided. Clear? Ne? Okay, now you can just play with these things. You are an assistant. Answer shortly. To the point. To the point. Okay. So I play it. Yeah, that's all. So whatever the thing, it was not mentioned in the text and other thing is not coming. Only Jayanthan Kulasinghe. Earlier say he is mentioned as something came. It's not coming out. Maybe we can say answered shortly with one word. Okay, let's see whether it's getting it or not. Jayanthan. See, Kulasinghe is missed. Makes sense. So this is what happening in the GPT. So you can prompt it as you want and you can get the output. So based on the chunk sizes and everything, it's done. Is that clear? Right? So this is the bot that we have built based on the chunk sizes. So nowadays, you do not want to create the expected question and answers completely at all. What you need to do is you have to upload a database, vectorize this, embed it, store it as a vector DB, vector database. And whenever question asks, you can go and ask about that. Okay. But now there is an issue. We will change the question. When the SIST form. Okay. Okay. Now I'm going to remove this chunks. Let's create the chunk. Okay. Scientific research, these are the chunks we are going to send because of the 200 words. So I'm going to here the same query when the SIST form. Okay. Going to run it and I'm going to remove this one word answering stuff. Full assistant. For instance, I formed in 2001. Is that correct? Maybe. It's correct? Yeah, 2001. Simple. Because it was there in somewhere in the collected database in these 200 chunk. But even if you reduce the chunk size to maybe 10, let's play and see how the thing is extracted. Right? Okay. Now the chunk size is roll of SIST maybe. It's not extracted over here. So it's not here, right? So it might not get over here as well. So the thing is, why if we if we are getting 10, there are no years mentioned over here, right? But if you increase the chunk to 200, somewhere the chunk fine with the year, right? How you decide the chunk size? So why can't we increase the chunk size to maximum and send all the things to there and get the very nice correct answer? Why can't we do it? Because for each query, we have to pay. Because we are not using the free version now. We are using these API keys, right? It's created by me going to OpenAI. You can create your own key and reload $10. Then you can use it for experiments, right? So for now, what is going to happen is if you go and see OpenAI charges, right? Type it out, pricing OpenAI. So when you go here, you can see GPT-4o. Right now we are using $5 per input tokens, $2.5 for batch API. There, this is the one, batch API. For how much? Yeah, 1 million. This is the one, GPT-4o mini. Okay, we are using 4o, right? 4o mini. We'll change it to 4o mini. Okay. So that's a large model. We have 3.5, 3.5 turbo, 4o, 4o mini, 4o turbo. There are many models available. So if you use this one, $0.15 for 1 million input token. 1 million input token means, for example, you are getting the query, getting the chunks, and sending it to GPT. So that is called as input tokens, right? 1,000 tokens are equal to 750 words. 1,000 tokens are equal to 750 words. So for 1 million input token, you can imagine how many words. There you will be charged 0.15. So when you increase the chunk size, what is going to happen? You are increasing the number of input tokens, right? So you are going to get charged a lot. So you have to optimize that as well. So therefore, finding the correct chunk size is really, really important to optimize the pricing. At the same time, when you reduce the chunk size, you might miss the answer. Correct answer. It will say, I couldn't find it in the thing. For example, let's go back here and PDF semantic search, right? These are the chunks. right? I'm going to go back to this GPT and I'm going to edit it. So these are the text chunks provided, right? For the query, I'm going to replace it. This is an answer assistant. That's the thing. Query is going to be when was the SIST FORMB. Okay. So now let's send this. Based on the text chunks provided, there is no specific information about the SIST was formed. The text chunks mainly discuss the role of activities thing. So this will be the answer. The chatbot will say, I couldn't find the information from the provided context. Why? Because based on the chunk size, that information is missed. So now while creating a chatbot, you are aware chunk size is important and tokens are more important because none of the institute will say, don't care about the price, I need a chatbot. So this eSoft has mentioned us, if is it $20 per month, we are okay. More than that mean we are not going to be okay. So that means you have to provide the chunk size exactly what they want, right? So that's the task as an engineer that you have to do. So now it's clear, right? How these chatbots, all these damn things are working. But another question. Now this GPT will give answer continuously. But in this one, every time when you send a certain query, it goes as a new thing, new chat. You open up a new chat and put the query, get the answer. But when you are asking a follow-up query, again it goes as a new chat, getting it done. So the answers will not be there. So how to overcome that issue? Now one answer, one question, one answer, totally fine. But in the chatbot, you are not going to do it. You ask a question. For example, we'll go to the eSoft bot now. eSoft Metro Campus and go here. Take a while to pop up here. So all these things matter. So for example, when you are dumping a lot of chunks, not only token charges increases, but also the bot becomes slower. Right? So everything matters. So here you click here. So I want to say, okay, hi there. I need to know about the HND courses available in your institute. Okay. So it goes through. What is happening now? This query, change it into a vector embedding. Then we have a vector database that goes through the vector database, identify the relevant chunks, 5 chunks or 3 chunks, right? Then it collect the chunks, send it to the GPT, and GPT restructure the answer from that chunk, get the answer and display here, right? That is happening. Taking time because its vector database is really, really big. Let's see how it's happening. So there are many other techniques happen. We call agentic approach. So that is little advanced right now. Let's say agent stop due to iteration limit the thing. So that's what it's happened. Okay, let's ask a new question. I need the price for HND in computer, something like that. Let's see what's happening because it's go through that and took long time. So it's a agent exceeded the thing. So this issue will come if you have a huge database and try to optimize the pricing. Campus approximately 1.2 million. Please note that this price may vary slightly based on the exchange fluctuation rates and everything, right? For more details, you can refer to that page. It's extracted the information. HND computer at ESOFT, right? HND in computer. So you can go there and you can monitor it. So is there any installment plan? So now what will happen? I am asking a follow-up question for the course fees, right? So that means the chatbot should know what the context I am talking about, right? So in the chatbot that we have built in the PDF semantic search, if I ask a follow-up question, it will not answer. Why? I'm just asking one question, go through the chunk, find, put it to the GPT, getting it back. If I ask a second question, go through it, find the chunk, put it in the GPT, getting it. If you ask a follow-up question without the context, you can say this answer. Yes, we do offer installment plan for our HND courses at ease of men. See, it's got it. It's know the context. So that is called a new technique, RAG, retrieval augmented. RAG generation, RAG architecture. So that is important. So when you ask a follow-up question, what now we are doing in the back end is usually when the question is asked, then it goes through the chunks, identify the chunk and put it and summarize what we are talking about, including the question and the answer, and it's saved to a memory, right? Temporary memory, right? Then you come back, ask the second question. It go to the memory, get the chunks also, and go through the chunks, identify the chunks, dump it to the GP. Then it summarize the whole text and save it in the memory. So when you are taking the third question, it get this chunk, summarized chunk. It cannot put all the things. So it summarize the answer with the query. It's a short format, short summary. It get that summary, your query, new query, identify chunks, all to the GPT, get the answer. So that's how the follow-up questions are handled now, right? Every time your question is saved as a summary over there. And when you are asking a question, it go to the summary, get that summary, go to that thing, vector database, identify the information, both together, send it to the GPT, get the answer and put it over there. That's how the GPT is following it up. Okay. We call it as a cache memory. So where we save those temporary files. Once you reload it, it will go again. Okay. So that is the key part over here. Cool. All right. So now input token is one thing. What is mean by output token? $0.6 for output token. Output token is the one. How many words GPT is sending back to me? Again, 1000 tokens means 750 words, right? So the charges will be estimated based on that. If you are sending more input tokens, generating a large answer at the output, your token charges are going to be high. So you have to say, talk shortly, provide answer shortly, then you can reduce the output token as a prompt. Clear? Is that clear? Cool. So that is the thing. Another part I'm going to introduce is Langflow. No, Langflow will come back again once we have time. Other one is, again, this is GPT using API. GPT is one thing which is basically started the LLMs. So now I will say LLM image revolution, something like that. LLM tree killer, maybe tree. Yes, there we go. Now we have this many LLMs. Right? I can scan. Yeah, see? So these are the LLM started 2018. There are Elmo, Almi. These are like large language model, but not that popular, right? BERT is a large language model we use for embedding earlier to give the semantic embedding. Still, it's not It's based on the recurrent neural network based stuff. After 2019, the GPT-1 was released over here, right? Around this time. Then GPT-2, and this time only they have released the GPT-3 that's came into user action. That's what we have used in the thing. After that, now we have GPT-4o and everything. So only thing we know is GPT, and there are a lot of GPT Neo, GPT J, GPT Neox, everything is there. And you can see how many large language models we have now. We have Switch, MT5, MTNLG. This is like, this is up to 2023, but we are in 2024. Now we have Llama, Lava, Code, Mistral, lot of models available, right? So if you take GPT, GPT is costly, right? To break the GPT market, what the Facebook has done is they released an open source model. You don't want to pay for it. You can simply download it and use it. Like that, the Google and many other competitors with GPT, they have released the complete free version. That means you can download it, install it in your computer, and you can use that to do your tasks, GPTs, right? So that is cheaper. You don't want to pay any token charges at all. You can download and put it in your computer and do the LLM task that it's doing right now, right? So what we are going to do now is, there is an open model called the other tutorial, AI chat with PDF tutorial. Here you can go here and find it out. Chat with PDF, that one. So there is a model called Sapphire 7B Alpha. We are going to use this one. This is a Mistral large language model, which is 7 billion means, okay, another thing. How many parameters GPT-4o mini has? 1.76 trillion parameters. What do you mean by that? So do you know the neural network, what we build has weights and biases, right? Weights and biases. So those are the parameters. So when we build a neural network with two input layers and 3 output layers, 2 connected to 3, these 2 connected to 3. So 3 plus 3, 6 weights and 6 biases. So 12 parameters, right? 1.76 parameters mean you can imagine the size of the AI architecture that the GPT has, right? 1.76 trillion parameters. So do you think you can download this in your computer? No way. It's going, you cannot download. It's huge model. So what the others have done is they have released very small models, 7 billion parameters, 1.76 trillion versus 7 billion. 7 billion is tiny, right? It's a tiny model, tiny parameters. They have trained it using the same data set. We have seen when the parameter sizes increases, the architecture got complex and complex. Sometimes the accuracy also goes good. When you reduce the thing, you reduce the size, the accuracy will go low. So these models are less accurate, but you can download it in your computer. You can download it into your Google Colab. You cannot download the GPT to the Google Colab to use free of charge, because 1.7 trillion you cannot handle in Google Colab. It will crash. It will, first of all, not download, right? It's not readily available to download. So nowadays we have 7 billion models, 12 billion model, 13 billion model. Those are small models, which we try to use it for our task, right? Next class, we will talk about something called fine tuning, right? A concept called fine tuning. These 7 billions are small models compared to 1.76 trillion large giant GPT. 7 billion is a tiny, small kid. But we can make this kid learn on certain specific tasks. He is trained for multiple things, understanding multiple things. He can understand law, he can understand Sri Lankan curry and everything. But the answer, you ask the same question to GPT, the same question to this 7 billion Sapphire model, the answer will be trash for this Sapphire model. Why? Because It cannot handle that question. It will give the answer, but compared to the GPT, it cannot answer properly. So what we do is we select this kid and we train him on a particular task. Let's say you are going to train your kid from your small, only identifying the colors, or else only doing this calculation using these, what is that, fingers and everything, abacus, right? Only you are going to teach the kid to learn abacus. And one kid is learning maths, science, and other things, all the things. Let's say one kid is only learning abacus to calculate faster, and other kid is learning all the subjects. Both are growing up to age of 6 or 10. Then you are giving a question, a mathematical question to this kid who learn only the abacus, and mathematical question to this kid who knows everything. The kid who learned abacus only will perform better because he was trained only on abacus. Will give a quick answer and the correct answer. But this kid know everything, law, this English, whatever the subjects. But he will give maybe a correct answer. Maybe it might not be accurate. So that means specifically if you train a kid on a certain task, even though that kid is dumb, he will be superior in that task compared to the kid who is intelligent in all the stuff. That's what we are going to do here. So we select this small guy. You don't want to handle all the things. We are going to train you on a specific task. So we create the scripts. We create the law scripts. If I'm going to train him in law, Sri Lankan law, I create the scripts only in Sri Lankan law and train him and fine tuning. So then this guy know in and out about Sri Lankan law, and he will answer any question related to Sri Lankan law 100% correctly compared to the GPT about the Sri Lankan law, because he knows Sri Lankan law, American law, all the laws. He is a general model, but I'm specifically training him these things. So that is the new concept. In future, we are working with Professor Jason on this task. In future, what is going to happen is, if you are working on, let's say, Python coder, there will be a model for you. You can download Python model, Python large language model. So you go to this Python large language model and say, I need to implement this website in Python. Couple of like designs you upload and wait, it will generate the right Python code. Now the GPT generates Python code. Most of the time it gives error. But you generate a Python code large language model only trained on millions and billions of Python codes, then it will generate correct code. Python specific large language model. Code Llama is a model only trained on scripts, computer programming scripts. It's better understand computer language, Python, C, Java, whatever the language is, better than GPT because they are trained on the computer language. So you are a Sri Lankan lawyer, you can get a 3 GB model, like small model, train on Sri Lankan civil law only and give it to him. Whatever the civil law cases, explain to this model and ask for the script to go to the court and just read it. You don't want a junior staff to find out these points and narrate the script to, nothing is needed. 3 GB large language model install in your computer. Ask this large language model because it knows the history of all the things happens in from independence to now. So you don't want to go through that to refer back, having 10 junior staff to go through all these books and identify this thing. No, memory is not needed anymore. So you just train all these things in this thing. He is superior in Sri Lankan civil law. The lawyer go to this thing. The client come to me. This is the problem that we have. Draft me a court debate thing. Then it will draft a very nice thing. He goes and read it. Right? So in future, if the lawyer can do it, if the model is available in online, why we need the lawyer? We go subscribe, I have this problem. Draft me the argument document. It will argue, print it, go, read it to the court, done deal. Lawyers' jobs are not secured anymore. Did I say that story? We have registered ASCII, and ASCII is the company that we have formed in US also, right? So in the US, we have to clear certain tax documents every year. So their lawyers are expensive. So the startup company organization is there. So they said within first 10 minutes, the lawyer consultant's fees is free, right? After 10 minutes, every 15 minutes, right? If you cross 10 minutes, you have to pay $50 for every 15 minutes. For the lawyer charges, consultants charges are very high. $50 for every 15 minutes. So even you take 10 minutes free, next 15 minutes, $50. Even if out of that 15 minutes, if you take 1 minute, again you have to pay $50, right? So like that. So it will go on, keep on going. So they said first 10 minutes free because you have registered with us. If you want take more than 10 minutes, then you have to ask question. So why we want to pay for a lawyer? Like we have a lot of questions. It will take longer time for us to clarify all these things from the lawyer. We went to GPT and asked the questions. I have this problem, and in American law, the deliver document, blah blah things. And can you help us? We asked all the questions. GPT gave all the answers. We know GPT gives answer, but we still do not know whether those answers are correct or not, right? So we went there to the lawyer. Meeting started. We asked, "Hi, good morning. We have few questions. So to do this tax claim, first of all, we have to submit this document, right?" He said, "You are right." Then second question. So once we submit, if you want to change the share level, we have to resubmit this document. Are we right? Yes, you are right. So the meeting ended up within 3 minutes. Zero charge for lawyer. Right? Because we got all the answers. We clarified whether the answer done. We are working with the UK consultancy firm in law firm where they do migration stuff. So to narrate the statement of purpose, all these things, they charge 500 euros to prepare those documents. Now, they prepare themselves, the clients, send it to the lawyer. Can you verify these are correct? His 500 euros is gone for applications, right? So this is how LLMs plays a major role in the thing. So GPT is a big giant, but he's not a specific giant for individual tasks. We can make it specific through these PDF, what we have done now as a chatbot or something, but still it's not enough. So rather than relying on the chatbots and everything, if we train a model who know the knowledge about all these stuff, that's the best. So that's what we are going to do. We are going to create a chatbot, PDF-based chatbot using Sapphire 7B, right? So this is one of the model. And here vector database, because we have to have the vector database. Let's say one document is fine. If you are going to deal with 10 documents, it's going to be crazy. Send PDF files, Google. So this is the thing. LangChain is the common thing that we are going to use to structure all these vectorization, tokenization. It's an open source library. So we are going to use this thing. So let's install the requested packages. So you have to run it. So maybe manage sessions. You have to close the other sessions that you do not want. Okay. Then run it. We are going to download this model from the Hugging Face. Hugging Face is a place where these people are hosting their models, one place. These are open. You can download it and you can use it in your computer if your computer have free space, right? Open source model. They are there because they want to compete with GPT, right? And these models are going to be the future actually, right? Because GPT is not free. Now, GPT knows who is the founder of SAST. Because the query went there, all the information related to this thing went there, it gathered the information. Next training session, Jayantan Kulasingam is going to be there in their database. So you just go to GPT and ask, who is the founder of SAST? It's going to come. You get it what I mean, right? So that means it's not secure. You are releasing your whole data to the GPT. So everyone would like to use closed models nowadays. So that means download your model, use it in your computer, your data stays with you, and fine tune it, your data get improved and the model response get improved, right? So that's the future of these large language models. So now we are conducting a couple of lectures, for example, projects. One is large language model. Next lecture, we will talk about multi-language model. Multi-language model means now we are dealing with text. That language model can analyze a video. That language model can analyze an image, everything, right? It can do all the tasks. Large language model, MLLM, right? So next class we will learn about that. So now we are doing a project in robotics. Earlier, let's say there is a robot. If you want to move from here to that back side corner, you have to take an image, estimate the path, do the path optimization. All these damn things is a lot of pain, a lot of time it will take. Now what we do is we are doing a project. There is a robot. You say the robot, hey robot, go to this place. That's all you say. What happens? You take an image with the camera and it send it to the GPT, identify the same thing. Hey robot, go from this place to this place is the command. So from this corner to that corner, and the GPT understand that and give you the optimized path route and generate the code for the robot, and the robot do the task simply. So whole robotic is gone now. It's going to go. Just you can do the robotics just by talking to the large language model, right? By prompting. And other thing, another project, one is in English, telling the robot to go to one place by commanding. Second that we are doing is Sinhala. You are going to talk to the robot in Sinhala. There is no Sinhala large language models available. What we are doing is we are downloading one of these Misrael kind of Sapphire model and we are fine-tuning it in the Sinhala text. So then it will understand. So when it's come to Sinhala text, the problem is tokenization, semantic, because Sinhala semantic router is not there. So the language model will not understand IBON means what. So there should be a semantic analyzing part we have to build up. There is a tokenization part we have to build up. IBON is a word. How the AI knows? It doesn't know. So mage nama location means mage nama location. There are 3 separate words. AI doesn't know. So first we need to build the tokenization to separate the words. Second, we have to build the semantic analysis embeddings, right? For each word. Then we have to do the training in the LLM. After that, you talk to this model. It will understand Sinhala. So that is called fine-tuning the model, right? Take an English model, fine-tune it on Sinhala text. Then it will understand Sinhala text. So that's the thing that we are planning on doing. Okay, I installed it, and LangChain community is the one. They are free, open source. They are building up a lot of libraries to do the tokenization, vectorization, embedding, semantic routing. They have all the stuff that you name it for LLM. They have it in them. So I have installed it. After that, I'm going to import this one. This is important to download the stuff here. So after that, importing dependencies, we don't want to know each and every code over here. These are important to download the certain model, right? So I'm giving the Google Colab Drive, LangChain, LLMs, and everything I'm importing here. Hugging Face is the thing that we are going to use for Hugging Face embeddings. And this model we are downloading from Hugging Face, right? Hugging Face is the symbol over here, right? If you go to Hugging Face, you can just have a lot of model I have shown earlier too, right? So there are text to speech, speech to text. It's an open source platform. You can use it. So now let's download this one. So it's a 4-bit thing. We will talk about this fine tuning and quantization a lot more in the next week. That is the future. So building up a chatbot, even anybody can do now. It's not a big rocket science. But selecting a model, quantizing and fine tuning for a particular task is a new thing. So if you know that how to do that, then you can lead the AI game. It's a competition. If you take a rest for a day in AI race, you are one day behind the other people. So you cannot take a rest. Every day new libraries are there. Every day the LinkedIn is posting like unimaginable stuff. If you go through that stuff, you cannot compete. So it's really, really hard, right? So you spend 1 month to do a project. Next month, the new model releases. Within 1 second, it do it. You don't want to do the training. So that's how the AI is crazy. So now we will download this stuff. So it's a 4-bit model. So we will talk about these next lectures in detail. Just now we will see how this model works. So it will take a couple of minutes to download all these things and save it in your RAM. So the same task that we are going to do, Instead of GPT, download this model and we are going to do that. Okay. It's downloading for you. Yeah. It'll take a while. So now it's downloading 7 billion parameters. Like that's a lot. It comes around 5 GB RAM space. When you load it to the RAM, it's around 5 GB needed. Minimum. Again, as I said, the sentence transformer that we have used is one tokenization model, right? An embedding model. But there are thousands of embeddings available. So basically, the LangChain embedding is one we are going to use here, and the Hugging Face embedding model is there, another thing. So there are tokenizers, lot of tokenizers available. So we will see. So for your chatbots, you can use these models. If you want to win the competition or something, other than using GPT, if you can use these private models, then you can say it's a secure chat, right? So your data stays with you, no data leakage, and it performs okay. Restructuring the answers, any chatbot is giving you good job. But complicated task, it needs some knowledge about that. So we'll see same document, same question we'll ask and see how it performs. So you can see Ola 1998 GB, Ola like big things are downloading. But this is one, but there are other language models also. You can instead of this language model, you can copy paste this one or copy paste this one or copy paste this one, and you can download other language models as well, and you can check the performances, right? Which is better for your task. Mostly Ola good in restructuring the answers typically for a chatbot purpose. But for example, if you give an image and say, explain this image, it won't do because these are not multimodals. GPT is doing. There is a multimodal called Lava, L Lava, right? So that is a multimodal. Reasonably, it's doing a good job. If you ask me which is better, GPT or Gemini or Crude AI or Lava, GPT is better, right? And Gemini is also better in image analysis, multimodal language. But Lava is okay, doing a reasonable job. But it's a closed source, open source model where you can download and use it in your computer. No harm at all, right? Your data stays with you. So that's the thing now. GPT is going to face a huge lawsuit in the future because of the data they use, right? So it's good. And other thing we'll say tokenizer. This is the define the tokenizer stuff. After that, we are going to talk. Hold on. Yeah, these are the tokenizers we are downloading. After that, let's connect to the Google Drive. Before going into the Google Drive, I want you to do something. Go to my documents, right? So go to the downloaded folder, create a folder called my documents. My documents, right? So, and load your PDF into that thing, SAST, right? And you have to go to your Google. Sorry, Gmail Drive. You have to go to your Drive. Go to your Drive and upload this one over there. So basically, you can drag and drop over here. Right, that's all. Once you drag and drop, then it'll get loaded and uploaded. After that, come to the AI and you can mount the drive. So we are uploading. So why we are doing it in this way? Because all the documents are now going to be in the Google Drive. So one document, two documents you can upload. So let's say 1,000 pages, 1,000 document you have as a database, you can't do it, right? So you have to connect to the Google Drive. So I'm connecting, so I'm giving this access to connect to Google Drive. Say approve, continue and continue. Then you will get connected. After connecting to the Google Drive, you can see here the my drive will appear here, right? Once it completed. Once it mounted, later on you can mount it at content drive. Okay. So once you go here, you can see my drive is there. Under this my drive, you can find my documents, right? And I'm running this thing, content drive, my documents. So whatever the folders inside the document, this is a PDF file name. So I'm going to load it as a database, right? So this is another way to load the database from the Google Drive rather than uploading manually. Because when you upload, it's going to be a temporary document in the tutorial. But if you upload to the Google Drive, it will be continuously there. So it's a good practice to maintain that, to keep it in a drive, right? So after doing that, so I'm going to load these document, tokenize it, giving a vector store going through the embedding. So I'm going to use the Hugging Face embeddings model here. Earlier, we have used the sentence transform embeddings model. So now I'm going to use a different one, Hugging Face embedding model, embed it and store it in the vector database, right? That is the thing, store it numbers in the vector database. And finally, I'm going to use the thing. So another thing, as I said, retrieval augmented generation. That's the one. After you created this database, we have to create a flow because we know you have to going to ask follow-up questions. If you are going to ask follow-up question, earlier PDF-based chatbot that we have built, it cannot answer because that's the way uploaded. You go through, ask a question, embed it, go through the embeddings, identify the correct matches, dump it to the GPT API, get the structured answers and reply. Done. When you ask another question, it's a new query. It doesn't know what happened in the previous chat. So no continuation is there, but we need continuation. So for that, what we are going to do, we get the query, get the answers output, right, from the GPT, summarize that, save it in a cache memory, right? When you ask in the second query, it gets this query, go through the database again and find the relevant chunks and the summary of this previous history sent to the GPT, right? Then you get the new answer, right? Then you go again and ask a new question, go through the vector DB, identify the right answers. You can do it right when you are, it's a large database. If it's a large database, you can do back to forth, right? Until you find the right chunk. So it goes one time and go through one iteration and didn't find, because cosine similarity search means it's going to search randomly, right? And identify this thing. Certain times the right answer chunks might be missed. So therefore what we do is we multiple times search through the document. So back and forth, right? So that's implemented in the RAG. So RAG is important to get the right answer from the PDF, at the same time continue the follow-up chat with memory, right? So I have explained this one. When you ask a question, this is the retriever. The retriever is the guy who is going to go to the context, right? Context is the one having the previous history versus the vector database. You get all these things. This is the context. It's understand the context and retrieve the information from the as a chunk, send it to the large language model, and the large language model provide the response. So this is another way we can respond. Okay, query, that's the question that you ask, is through the embedding. Go through the embedding, go to the vector database, identified all these chunks, and these are the retrieved chunks, put it to the LLM. And the query also go to the large language model and it gives the response. And the memory will be updated for each stuff. Okay. So not every time it will be updated. So you will keep the context all the time, what we are talking about, right? Otherwise, every query is going to be a new thing, right? So that's important. So whatever the things that we have discussed is mentioned over here. So let's build the RAG architecture. This is the architecture based on the OpenAI, LangChain model and Hugging Face. So just build the RAG architecture. You don't want to worry too much. You can copy and paste while you are building it. Okay. So then we are going to our normal create a GUI. So this is a GUI model that is supported in Hugging Face. So you can open this link in your thing. It will come up over here. Now you can chat with the documents. Okay. So this is a UI. You go there. There is a link will be provided. You click that link. It will route to that thing. Chat with your data. Sapphire 7P Alpha. Okay. What is this document about? Right? It goes through the model, goes through it. What is now happening? The RAG thing. Query embedded, go through the vector DB, identify this information, retrieve, go to LLM. LLM is now running in our computer, not in GPT. So in our Google Colab. So it will be little slower. If you have a good machine, it will have a good thing. So now you can see Use the following pieces of context to answer the question at the end. If you do not answer, just say you don't know. Don't try to make up your answer. So this is the prompt that we have sent to the Sapphire model. And these are the context. It is retrieved from the information through our RAG architecture. So you can find out Krishan, something. This is one chunk. This is another chunk. This is another chunk. So these are the chunks that we have identified, right? So now the final answer, what is this document about? The Sapphire model gave is, the document describes the genesis and mission of the University of Mysore, which was established through 5 years. Is that the correct answer? No, it is not, right? Because we uploaded the document about SIST. It is answering about Mysore. This is the problem with the small models, okay? So the context also, see, it didn't talk about SIST anywhere. SIST believes it's there. Let's read the answer. The document describes the genesis and mission of University of Mysore, which was established through 5 years research. And the document also highlights. Then we will ask, isn't this document talk about SIST? This is a follow-up question that I'm asking, right? Same thing is going to happen. It go and it's going to go there, retrieve the text related to that, and it's going to answer the question. So these are the chunks. This is the prompt that we have sent to the GPT. These are the identified chunks. And now this is the answer. Yes, this document is primarily about SIST. It describes the institution history, patterns, collaborators, academic and research program, campus facilities, life SIST, alumni admission and research. Who is the founder? Okay, now I didn't put the SIST name, right? Because why is that? Connection error, okay. Yes, it says yes. Who is the founder? I didn't say who is the founder of SIST, right? I just say who is the founder. So it should know I'm talking about SIST because based on the retrieval architecture. So these are the things. Let's say the passage does not mention the founder of the Futures Entrepreneurship Plymouth Business School, UK. So that's the problem with this large language model. But if you ask this one to GPT, it will definitely answer because it's 1.7 trillion. This guy is 7 billion, small guy. So, but fine tuning these models, we'll be able to improve the clarity, right? And we can play with the RAG architecture to define the chunk size and everything. So max length is this one, see? So we have top 5K. So by adjusting this parameter, we'll be able to get this guy answering to a certain level. Now I'm going to ask another question. Who is Jayantam? But when you are using these smaller models, this is the problem. They are not accurate enough to answer as GPT. GPT, it answers very nicely, right? Jayantam Kulasingam, chairman of Spectrum Institute of Science and Technology. See, it's giving. So that's the thing. So it's not always correct. It's try to answer and restructure based on the context because it identifies the chunks, but it should understand the chunk. So that ability is based on the number of parameters and the way it's fine-tuned and trained. So now it's you build up a chatbot using your own downloaded language model. It's working, but still I can eliminate this printing option here. I'm printing these things now. Demo, you can just put chat with your data Sapphire Alpha. Okay, then you can limit those printing option here. Only the answer and KIST can be enough. So nowadays, now I have result QA chain is there. Query, chat history and chat history append. All these things are visualized over there. You don't want to mention that, right? You can just clear out only question and answer, only the answer here. You don't want to mention it there. By disabling that part, you can completely disable this. Only question and answer will be there. You can continuously chat. To show how these chunks are retrieved, I just put it over there. When SIST is formed. So now you can build a chatbot using RAG architecture, using GPT for SIST and host it in your environment. That's all simple. But always we have to be very careful about what we are talking about, because the large language model is not well enough. GPT is super for chatbots, but you are leaking the data, right? So see, now made it possible. See the answer. The question I have asked is when SIST is formed. GPT gives 2001 correct answer. Now it's giving, see, SIST has now made it possible for professional, all in SIST has never mentioned the year at all. SIST enters 19 years of age. This is not the answer that we want. Why it is happening? Because we are using a small baby to answer. That is this guy, Sapphire 7B. Right? So makes sense. If you fine tune it, it's going to answer better. Right? But that's little too much to do the fine tuning part at this stage. Maybe in upcoming few courses, if we want, we can go ahead. Right? So now it's clear, right? So we have built a chatbot using GPT, using API keys, and we have built a chatbot using a private model, open source model, download it to our platform, and we are asking. So you can see the performance difference. Same question asked, different answers. Answer quality over here is very low. But this is going to be the future. You can improve the model performance by fine-tuning it, right? So there are a lot of fine-tuning, quantization options. We will talk about that during the next lectures. Any questions up to now? Is that clear? What we have learned today, right? Okay. So now chatbot means anyone talking, you know what is happening. It's not a big deal at all, right? I know what you are talking about, Kela, you can say. When it's introduced earlier, yeah, it was a hot thing. Chatbot is doing a great job. Like it's going to get the job from the customer clients, and the phone call managing people. Still, it's not. But in future, it will. GPT 4.0 Turbo is super crazy. 4.0 is super crazy. It can do any task. You can. So we have done a project to analyze videos. Let's say there is a movie, right? There is a movie, and this movie is made, but 2.5 hours movie, right? So you have to analyze a movie for marketing and identify certain clips in the movie to promote that movie to a certain type of people. So let's say I like the action sequence, right? So there are people, influencers in the market who talk about movies, right? Movie reviewers. So those movie reviewers highlight more about the action sequence. Fight is good, superb movie. They have done an amazing fight job over here, like that, right? So those fans for that movie reviewer actually is going to attracted towards that action sequences. There are certain people who are looking for story. So there are certain people who emphasize the story in the movie, they review the movie. Those people have the like fans who are addicted towards story. So now, if you want to promote a movie, you contact that guy and you have to show a clip which the action sequence is good, where he can promote the movie using that clip. He's an influencer, right? In his TikTok, he can say, there's a movie coming up. See this video, guys. This is crazy, like that. So for that, we had to identify in the 2.5 hour movie, which is the right clip to send it to this guy, which can attract this set of audience, right? Then you are going to promote the same movie through different clips to different target audience. Finally, all the audience are going to be attracted towards your movie. You are going to earn much. One example. right? To do that, we are using LLM, private model. Because you can't put the movie to GPT. GPT know the story, then the movie is gone, right? So you can't put it to GPT. So you have to keep it private. I'm going to keep it private. So we are building up a model for kind of stuff over there. So it's there are a lot of work going on. It's like unimaginable work by AI. It's going to improve the marketing, improve the revenue, reduce the losses. So there are a lot of stuff, right? So we are working on those stuff. Later on, once that project is finished and signed, we handed over that project, we'll be able to talk more about that in the classes. But it takes a long time. It's a big project actually. So the Lava model actually did a really good analysis, and it identified the scenes and gave us the scenario. These scenes will be liked by this kind of people. So that is called persona, user persona. So then we identify an influencer who has this persona audience. Reach out to that guy, send this video clip, say promote my video. I'll pay you this much. Done deal. So be an influencer if you can as soon as possible. The influencers are going to earn a lot of money in the future based on AI. And for example, these food reviewers, how much they earn? They get free food. On top of that, they get money from the shops that they review. Based on the view, they get money through YouTube and these things. Crazy, right? Like free food, money from the per food shop that you are reviewing, plus views. You don't want to study anymore. But that's limited. That's an art, right? So the way you review the food and everything is an art. And nowadays, there are a lot of people in Sri Lanka started that. That's true because before I try a new restaurant, I go and watch their review, right? And then only I go, right? Their Crazy PR YouTube channel or something. They review a lot of food in Tamil, so I watch that thing. There are multiple single channels also, and they promote somewhere the outing package, middle of a forest, some hotel. Yeah, but people are going there because of these people, right? The audience analyzes. So that's influencers are making a lot of money. So AI is going to get use of that thing, and it's going to promote those stuff. So we have to be upfront in the market to do those stuff. So now it's clear, right? How the chatbot works. You have the whole history about chatbot. You can build your own chatbot using a GPT API keys or using a own language model. But the problem with the own language is responses are not that good, right? But you can fine tune it. Try it with multiple models. I have added a couple of other models which will support the same code. You can download that model to use that one. So just change this instead of this, and instead of this, copy and paste this over here and run it, right? Then you can see how for the same question, the model is performing differently, right? All right, cool. With that note, we'll conclude today's lecture session. Next week, we have one. So next week is going to be 11th, ne? Okay, so I'm traveling to China for 2 weeks, right? 14th, 13th, I'm going. I'm coming back on 29th. So we may miss 2 lectures in the middle, right? If Para is okay, if you guys are okay, if I get time in China, I can conduct it in online, but better in person, right? Better in person. So we'll come and conduct back-to-back sessions, even 4-hour sessions, 2 tutorials together. We will finish it up on that time. 11th, Professor Jason Mars is coming to Sri Lanka. Still, I don't know when he is going to arrive. If he is arriving in the evening, we'll conduct the lecture session next week. If he is arriving in the morning, I have to go to airport to pick him, right? So I will not be available next week. I will inform you early, right? So other thing is, there will be a tech talk session in University of Moratuwa by Jason Mars. I will invite you guys. You can also come and join that session, right? Over there, whenever, if you would like to, you can say I came to there. Tell my name, coming to meet Logi, and they will allow you to come in, okay? The university entrance. And yeah, that's all from my side. So I will let you update you, okay? Based on Jason's flight, I will update you. I hope if he comes in the evening, I can come and finish the lesson and go and pick him up. Yeah. So one more session, 13 week, 14 this chatbot. After that, there are 4 sessions. Those are very simple things. We'll finish it off. We are not going to build up stuff. We are going to use the existing libraries and play with it. That's all we are going to do. Okay. Okay then. Cool. Until then, bye bye.